Good afternoon. Today we're going to have the virtual session for the Masters in Chemical Sciences program at the University of Pennsylvania. My name is Dr. Tina Morgan Ross. I'm a medicinal chemist and I'm the Associate Director for the program. I have a PowerPoint presentation that I'd like to go ahead and share and tell you about our program. So welcome to Penn. This is our chemistry building. This is one of the newer sections that we share with engineering. And we really have an integrated department with a lot of different research groups. We're a part of the School of Arts and Sciences and also the College of Liberal and Professional Studies. And we're embedded within the Department of Chemistry. This is a professional master's program. This helps focus on helping you find a career after graduation, and it can also prepare you for a PhD program. We really work towards having our students gain skills and professional development. It's designed for recent graduates and working professionals. It has a 2-year compact time frame. It's full-time, but we do have part-time students as well. Maybe they're working nearby and they just want to get a master's degree. So we're flexible. You have access to state-of-the-art research facilities, and our students take the courses, the same courses that the doctoral students take as well. We have quite a number of areas of focus, and I also wanted to show we're getting a new chemistry building built, and this is what it will look like. I think it's supposed to be ready in 2024, so we're really looking forward to that. We also have synthesis and characterization of new compounds and materials. We have areas of chemistry of life processes, nanoscale materials and molecular devices, chemistry of the environment, and energy, which is super huge, and the hydrogen economy. The chemistry department is 4 buildings totaling 166,000 square feet. It has multiple facilities and centers. This is on the right is the oldest building, and this is the 1970s wing, which is where we are located. We have a great scientific infrastructure. We have a nuclear magnetic resonance NMR lab. We have 10 NMRs, 1 600, 6 500, 1 400, 360, and a 300. Our mass spec facility has a GC mass spec, multiple LC mass specs, LC top, high-res mass spec, and we have that ESI or CI capability. We have an X-ray facility with the diffractometers, and we also have the Biological Chemistry Resource Center, which includes shared instrumentation with the MALDI-TOF, PrEP HPLC, and peptide synthesis lab. We have a cell culture facility. We also have a scientific glass blowing facility, which is really great. Anybody that's needed to design a specific type of glassware for a reaction, it's great just to be able to walk downstairs and show them a sketch and they could be able to do that. So that's a really great resource. We also have chemistry computing, various servers and clusters, and both are department owned and also the principal investigator owned. We have molecular modeling, software packages, Cambridge structural database, and these are all available through the library or open access to everybody. We have high throughput experimentation facility, and this was started as an NSF funded collaboration between Merck and Penn Chemistry. The curriculum is what's called 10 CUs, and that's like 10 courses. And they're about 3 or 4 credit regular courses. So It's 30 semester hours. You have a pro seminar, which is 1 CU, it's required. Then you'll have a core concentration, which is 4 to 6 CUs, elective courses 2 to 4 CUs, and then an optional independent study, which is 1 CU. And then you have applied research capstone project, which is fundamental for our program. We have 6 different concentrations, so biological chemistry, inorganic chemistry, organic chemistry, physical chemistry, environmental chemistry, and materials. And in environmental and materials, we have different concentrations as well because it's such a broad area. The capstone requirement is an applied research project to highlight the skills and knowledge you've gained in the program. And it focuses on your career goals, can work with your current or potential employer, and it has applied projects that are preferred over theoretical. So it's hands-on. So the capstone process, during your pro seminar where we review like ethics and your research faculty get up and tell you about their research, and you go ahead and select a faculty advisor, you identify your research interest, you identify a research supervisor, which we call a secondary reader. You then prepare and submit a proposal of the type of research that you'll be doing with that research supervisor. And then you'll work in the lab 6 to 9 months. You'll prepare a capstone report, and then you'll also give a seminar and talk about your science to either at a major conference or to your peers. We're very unique. We're closely situated, of course, with Penn Medicine, which has a huge research capabilities, and those different departments love our MCS students because they're serious students, and they really work diligently on the research projects. So there's quite an opportunity for not only within the chemistry building, but also close by at Penn Medicine. We also have affiliations with other institutions. We have one in Saudi Arabia with King Abdullah University of Science and Technology, Monell Chemical Census Center, GSK, USDA. We have a chemical and nanoparticulate synthesis core that some of our students work with, Exalta, the Bloomberg Institute, and the Wistar Institute. And it really gives the students a really nice experience of a specific area of research that they're interested in. These are some of the projects that the students have presented in the past and worked on. And as you can see, it's a variety. I've chosen materials inorganic, which is synthesis of optical properties of rare earth doped fluoride nanoparticulates via enhanced absorption, the roles of the taste receptor, T1R3 mediated pathways and systemic inflammation. So that will be more biological. Molecular basis of encapsulation of positively charged green fluorescent protein by ferritin, that's another biological. And then nutrigenomics of the gut microbiome, that's another biological. Then drift ligands for nanoparticulates, and that's inorganic. And then the single electron transfer, live radical polymerization of nonpolar monomers, that's organic. And then electronic spectroscopy of methylacrylene oxide, a 4-carbon Crij intermediate from isoprene ozonolysis, and that's physical. So a lot of different areas for our students to work with a faculty member and learning research. We also have, and this is pre-COVID, seminars where the students will present their work, and of course food. And we also, since we're so close to industry, we'll invite in, and some of them will be open to those partners in industry. We do networking, mentoring, professional and communication skill development, and our students are highly sought after in industry. We also have fun. We make sure that we have opportunities for the students, not only to work really hard, but also to take breaks and have fun and build those relationships with people that will be their peers as they go through their careers. And this is at a museum, and this was a couple weeks ago when it was snowing. We had a team building where we were making s'mores. So our statistics right now, we have 52 active students, 38% female, 64% male, 82% are full-time. We have an average of about 20 students admitted per year. We have about 66% international students, and they're from all over. We have the unique thing for our international students is all of our concentrations are science, technology, engineering, math. You can also do an internship, which would be a CPT available after your second semester. Then you can, after you graduate, you can have an OPT, which is actual practical after you graduate. So it's a really great opportunity. Your typical major, students are not all chemistry majors that we accept into the program. We do require a strong science background, and we do need at least 2 semesters of calculus, inorganic chemistry, organic chemistry, and physics. We have alumni at various institutions around the country and internationally. And so our students sometimes go on into doctoral programs, or sometimes they go work in life sciences as a director or a point of contact. We have about 45% of our students go on to doctoral programs, either at the University of Pennsylvania Chemistry Department. We have a student that went out to Texas for pharmacology, and then also UCLA for biochemistry. Application deadlines for fall 2022. We have a March 15th, but we will look at applications a case-by-case basis. We have CollegeNet application online that helps us with the application process. You need to have an essay. There's an application fee of $75. You need transcripts. You need to provide a copy of your resume. TOEFL scores are really important, and 2 letters of recommendation. I recommend 3 just in case 2 are submitted, then that's fine. And then GREs would be helpful as well. If you have any questions, my name's Dr. Tina Morgan Ross, and Rye is our program administrator, and be happy to answer any questions that you may have.